Yesterday we only until the octal and hexanemer to binary conservation.
We until BCD, right? Yesterday. Not here. Until here.
We didn't reach into the module 2B.
Oh, am I dreaming? Isn't it? I think
Or
zero.
different sections.
I think 06 is much more faster than 03.
We are just 6, right?
Wait. Luckily there is another person who coming that. Hey, no. Wait. Amir Muhammad. Wait, I double check. Yesterday. Yesterday we already finished the octal and hexadecimal conversion, isn't it?
Yeah, we yesterday only reached here, didn't go into module 2B.
Oh, okay.
Because doctor yesterday got meeting, right? Yeah, so we end earlier.
Okay, sorry. Thank you for reminding me. This is my age factor. Okay, now yesterday we did take a look into our conversion, which is on binary to decimal to any base number, to decimal. And then we take a look into how you're going to convert from octal and also hexadecimal to binary, and binary to octal or hexadecimal directly using like separating between like 4 bits for hexadecimal and 3 bits for octal. But you need to also remember you have two types, which is the integer number and also your fraction number. So that is a way for you to convert. Please make sure you still remember our previous class. If you, let's say, have a problem with that, you can WhatsApp me. If let's say you do any example or any question from outside, you can just also ask me. But I prefer you to like share in our group so then we can learn together instead just one person learning. It's better for us to learn together. And yesterday also, I guess 2 students asked me regarding your test 1. That's why last night I share the schedule. And there is, I guess from section 03, the student asked me why it is on Saturday. So I guess I already informed all of you why we need to do on Saturday. And I also already informed about our test 2. It will be 1/1/2022, which is New Year. So I hope that you take note, and you can also check in your CI, course information. There is a date, there is a subject which is that will be covered. For our test 1, it will cover only module 1 and module 2. That's why I want to finish our module 2 as soon as possible. Then we can focus on our revision, our mock test. Maybe also we can start our lab next week. Okay, next week we're going to start our lab. So please make sure you install the DIT simulator. I still didn't bring my computer to my office. Maybe tomorrow, because Sunday and Monday I have class since 8 until 4 p.m. Okay, now this is yesterday's story, and today we're going to look into our new module B2, which is we're going to play around with codes. There is several codes that you need to remember. But before that, this term is very important. You're not going to use this only for digital logic subject, but throughout your years at university, you will somehow will meet this again. Although you think, I really had this kind of person, I don't like bites or I don't like to remember words, but of course you're still going to meet them. And next semester there is COA subject, you also will find this kind of things. So bit is basically the single value that you have, the single integer that you meet in your numbering system. It called as bit. 1 bit, 2 bit, 3 bits. So bit per bit. Normally you send your data bit per bit. So this is bit. And nimbles have equivalent of 4 bits. If you have 1100, it means that this is nimble. You're going to also use that in like network header. Somehow you will notice you will have like, okay, for your network header you have this certain length which is maybe 6 bits. So how many nimbles you have? Maybe you have 1 nimbles, 2 bits. So you need to know on terms of the words and how many bits that is represent. For byte is going to be 8 bits and for words is going to be 16 bits. And normally, okay, sometime in our question we will like already give you a hint how you're going to answer. But if let's say, okay, normally we will separate the number. If you have the long kind of numbers, let's say we have, I just show you 1 1, okay, 1 1 1 1 1 1 1 1 1 without any space. It's very hard for you to, how many are 1 2 3 4 5 6 7 8 9 10 11 12. You need to calculate it and it's very hard. That's why in our numbering system normally we will separate it 4 and 4, which is nibbles with nibbles. So our number will be like this: 1 1 1 1. There is a space. 1 1 1 1 space 1 1 1 1 1 1 1 1. So this is kind of this. So you know, okay, this 4 8 12 16. This is word, one word. This is 1 byte. This is 1 nimbles, and this is 1 bit. So it's easy for you to know. So that's why there is a space. Normally in our digital logic subject, in question also we will have separate. I just share with all of you, okay? For COA subject, next semester you're going to go for COA subject. In the question, sometimes we ask you to write the answer because it's directly marked by e-learning, so there is no space. So please make sure that you carefully read the question, and yeah, if there is no space, it's quite hard. But you're not reached for COA subject yet. And this DL, I just show you, then you know, okay, supposedly it's easy for you to have space. If let's say you need to answer also, if you want to submit a question, also you know, okay, this is 12. You already calculate this is 12. Or maybe this is one word which is 16 bits, right? So, but when you submit your answer script, your lecturer will like, how many bits this is? So it's hard for your lecturer also to mark. So please make sure you write like this, and then there is a space, another 4 bits, space, another 4 bits. So the purpose of this part slide, please make sure you remember how many bits for nibble, how many bits for byte, how many bits for words. The byte in the bits in a byte are normally number from 0 to 7. This one you already know. For let's say you have 8 bits. Had bits, you know you have to the power you have 8 possibilities for bits. But you can try to read it by yourself over here as long as you remember. Okay. You also already look into MSB and LSB. LSB will be at your right side before your radix point. And you can see this is your LSB. And for your MSB, it will be your left side for your number MSB. So in one byte, you have 2 nimbles. You already know that nimble is 4 bit, and then for 1 byte, you have 8 bits. Altogether will be 2 nimbles. So you will play around by versa for conversions. If let's say 4 bits over here, you have 1 nimbles. Can see 1 nimbles is only 4 bits. And majority where you're going to apply this, you're going to apply in your BCD codes. Later on you will learn these codes, and also normally you play around inside the hexadecimal number. So these numbers, this is 4 bits, and where you apply these numbers. Oops. And next, let's take a look into, okay, this is example. Just example here, you can see. Next is our bytes. Our byte, we have 8 bits altogether. 1, 2, 3, 4, 5, 6, 7, 8. 8 bits, and altogether total is 256. This one you know it's already. And where you basically use this byte is in numbering numeric value, sign number. So you going to apply this, and for the words, you have 2 bytes, you have 4 nimbles, you have 16 bits, and the value is to the power of 16. This is the total value numbers that you have, including 0. Including 0, okay? That's why you're going to start from 0 to 65536. All together 6, including 0. And where you're going to apply this, you're going to apply in signed integer and unsigned integer number. So for this kind of bit, nimbles, byte, words, is there any question? Are you okay for all of this? If okay, we're going to move to code. If you have any question, you can interrupt me, okay? But you can just always interrupt me just to take a break from learning. It's very good also. Okay, what is code and why we need code in our daily life? It is also sometimes as a short form. Instead of we have long versions of, let's say, the very simple one when you learn assembly language. Assembly language, you're going to have a simple command. Let's say you want to move this value of 10 to your register EAX. Let's say this is example. You will like confuse what is EAX, doctor. I still not yet learn. I said this is example, but you want to move this value of 1 into register. So in our like programming, if you have programmer friends, programming will play around with programming, you know that they are very lazy. That's why they have like shortcut to make the program simpler. So if like move, they have like shortcut for MOV. If let's say they want to have a multiplication, they use MUL only, similar to our keyboard. If like you want to screenshot for my MacBook, I'm going to press Shift 4, something like this. So this is shortcut. So that's why this is like a code for me to do and to come up with some activities. So the purpose of code is it is unique. If we do like Shift 4, it is unique for only screenshot. So it's unique and easy to process, easy to represent, enable communication, blah, blah, blah. And same goes to UTM. This is representations like short form for University Technology Malaysia. And we can just, the codes for UTM or the short form of UTM. This is University Technology Malaysia. And that's why in our machines also we have a code just to make things easy for us. And this is several code that available what we will learn in our digital logic, which is BCD, gray code, ASCII, and parity code. BCD is much more simpler, but sometimes it's like a confuse, only that you need to have limitation. We will put limitations, and it is similar to binary and decimal. That's why it's easy for you. There is like invalid code for BCD. Only that make it different between your normal binary and decimal converter. And then you have the gray code. And then ASCII code, you're going to have also table. Gray code also no need for gray code. There is no table for you to remember. Parity, there is a table for you to remember. ASCII, no need for you to remember, but if let's say for test, they're going to provide you with the table because the table is very huge. You cannot remember all. Let's take a look one by one. Now we go for our BCD, binary code decimal. We will only have range with this, which is there is only 10 groups of BCD system from 0 to 9. It's quite similar to your hexadecimal, which is you have like 4 bits, but instead you just stop until here, you not continue for A, B, C until F. So the value of 11, 12, 10, 11, 12, until 15, it is invalid, which is represent as 1, 1, 1, 1, 1, 0, 1, 0. So here, let me show you what is the invalid code. This one is invalid. Why it be so? Because you're going to see to the power of 4. 4 is what? Your bit number over here. You're going to get 16 supposedly. That is 16 possibility. So it is from 0 to 15. Similar to your hexa numbering system. But in hexa, A will be 10, B will be 11, until 15 will be F, right? But this one will be not available in your BCD code. BCD code only until 0 to 9, but it's 4-bit. And the rest will be invalid. There is no cover in your BCD. It will be similar things. You convert 0 from decimal to BCD code, binary, code decimal, which is 0000. 1 will be 0001. You need to have 4 bits. So this is your code for BCD. Example, if you have this number 3245, you need to convert one by one. 5, 4, 2, 3 to BCD. 5, we know it will be 4, 0, 1. This is your normal 5 version. But again, as I mentioned, in BCD, you need to have 4 bits. Don't forget to put 0 in front, because if you combine, if you forgot to put 0 here, your answer will be wrong. The value will be totally wrong. Okay, then you put 0. For 4, you will get 001. And don't forget to put 0 also. And 2 will be 10 only. And because it is 4 bits, you need to put 00 in front. For the 3, you have 11, put 00 in front. So you combine it together, you will get 0011, 0010, 01, 000101. So this is basically the answer. So you're going to convert one by one. And don't forget the value of 4 bits. And next also you have the similar things. You can just directly convert it. This is your BCD code. Okay, why you always like play around with conversions of 0101? Because when you press, let's say again, when you press in your keyboard 7, 8, 4, 8. So what is your computer will get is this value. Because computer only know the machine language. Machine language will be only 010101. So we also don't know, and we did not understand machine language. That's why we need to have like assembly language or any programming higher level of programming to convert in our understanding language to be understood also with our machine. Okay, before we continue with gray code, do you know that we're going to have exception or holiday for next Sunday? Upcoming Sunday, not next Sunday.
Yes, doctor.
So that's why I want to try to finish as soon as possible, because we're going to have also Later the update DG form as well the GPS. Forgot. Okay. Then we're going to continue with grade codes. Why I love this grade code? Because as I mentioned, I love mathematics. In the grade code, we have methods to apply with like adding thing. Mathematics, although it is like a simple adding. I don't want to read. Please read by yourself. And don't complain that your lecturer lazy to read, because I really don't like to read. I don't know how I can write a novel last time because maybe I need money, but I never read novel also. And when I am student, I think I never go to library. There is no way for me to read, especially books. Okay. Over here also there is a simple like equation for you to learn directly from here, but I not allow you to use this picture or this kind of method. It's very hard for me to understand also, but if let's say your brain can understand, you can proceed. So now I'm going to direct to example, then you can see it clearly. Let's say we in our grade code, you only have two ways, which is whether you need to convert your binary number to grade code, or from grade code to binary number. This is only virus setting, only two things. That's why you only to have two methods. So first, let's say we look into how the method, if let's say you were given a question for binary and you need to convert to gray code. You need to write like this kind of table. If you don't want to write a table also, you can just assume this is binary. If you have this kind of binary number, first thing you need to do, you need to maintain your MSB value. You convert it, you go for convert, and then you bring this maintain MSB, you bring down, and you assume this is your gray code. Okay, this is your gray code. And another one more things, if you still remember in our earlier class last time, I always show you that if you have 0 plus 0, you will get 0. This is your sum. 0 plus 1, you will get 1. 1 plus 0, you will get 1. Sum. 1 plus 1, as I mentioned last time, if you still remember, you have 1 plus 1, you will get 2 in decimal. And in your binary, you will get 1, 0. What my senior one? What is this? Meeting petang ni. Meeting lagi. Ayo, yo. Siti. Later I reply her, but I need to forward. It is important about meeting. Let me silent rather than vibrate. Okay, now you need to know 1 plus 1, it will be 2. but in binary it will be 1 0. This is sum. This is carry. This one I just recap because I already teach you last time. Okay, so you have sum, you have carry. What you need to do if you have 1 plus 1, this is sum, this is carry. Okay, why I need to recap this? Because you're going to apply in this method. Okay, in this binary number, what you need to do is you need to add. 1 plus 0 is 1 for the sum. You bring the sum down. 0 plus 0. 0 plus 0, you will get 0 as a sum. This is your gray code, okay? 0 plus 1, you will get 1. 1 plus 1, you will get 1 and 0. You need to bring your sum only. Your sum will be 0, and in your gray code, you need to discharge your carry. So your carry, you will be discharged, and this is 1. Maintain your MSB. Second, discharge your carry for gray code. You will apply it whether you want to convert from binary to gray code or gray code to binary. These two things you need to remember in gray code. Maintain your MSB, discharge your carry. So if you have 1 plus 1, you will get 0. And last thing, you will have 1 plus 0, you will get 1. So the answer will be like this. 0, 0, 1, 1, 0. If you convert to your gray code, you will get, this one is passed to your binary number. You will get 1, 0, 1, 1, 0, 1. This is your gray code. This is how you convert. Let's say you have another example, 1, 1, 1, 0, 1. Okay, this is your binary number. You need to convert to your gray code. What you need to do is 1 plus 1. You will, this one first, maintain. This is your gray code. Maintain, and then 1 plus 1, you will get 1, 0, but you will only take the sum as 0. 1 plus 1, it will be 0. 1 plus 0, you will get 1. 0 plus 1, you will get 1. So when you convert to your gray code, you will get 1, 0, 0, 1, 1. So this is very simple step, but in terms of very beautiful things, it is on a table like this. First, you will maintain the value of your MSB. And you will do the adding. You add the value 1 plus 0, you will get 1. And next, 0 plus 0, you get 0. And next, 0 plus 1, you get 1. Now, this is a tricky part. 1 plus 1, you will get 1, 0. You will take the sum. Your carry will be discharged. You take the sum, you discharge your carry. These two things you need to remember in your gray code. And then continue. 1 plus 0, you will get 1. 0 plus 1, you will get 1. 1 plus 0, you will get 1. So as easy as makan kacang, you get the answer. Any question? So this is the way for you to convert binary to gray code. After this, in next slide, you're going to see gray code to binary. It's slightly different, but these two things is maintained. You're going to apply this one, you're going to apply this one also. Only in terms of the way this one you like dragging down, you just add like this, vertical or parallel way. And for the gray to binary, you will look that you're going to apply that zigzag thing. Only that things that makes the difference. Rather than else, no need. Okay, go for next. Let's say I have my gray code. I want to change and convert it into binary. Okay, this is my gray code. 1 1 0 1 0 1 1 1. As always, my font will be ugly rather than compared to the computer one. So I need to remember gray code, Dr. Sid. I need to maintain the MSB. Okay, I will bring down. This is my gray code and this is my binary, my binary value. I need to maintain. Okay. Next, this is not binary to gray code. I cannot add like this. Instead, I need to apply zigzag method. So this one, what I need to do is the answer when I get for my binary, I will do like this, zigzag. So I need to plus 1 plus 1, then I will get my answer for my next binary value will be 1 plus 1 will be 0 for the sum, and carry. The number 1 I need to remember is carry will discharge. So I will take only 0. I repeat again the zigzag thing. I will add over here 0 plus 0. I will get the answer of sum is 0. And over here I will add 0 plus 1. I will get 1. 1 plus 0. I will get 1. 1 plus 1. Again, I meet this situation. I will take 0 only. Carry will be discharged. 0 plus 1, I will get 1. 1 plus 1, I will get 0. And carry will discharge. So that is the only difference between binary to gray code and gray code to binary. Gray code to binary, it is zigzag, and binary to gray code is direct adding like this. Okay, so let's take a look in proper way. You have the gray code and you have the parts that you need to put your binary value, of course. First, you need to maintain your MSB, and then you're going to apply the zigzag things. This value of your binary, the one that you get, you need to add on with the gray code. 1 plus 1, you get 0, and you discharge your carry. Again, you will repeat the sum. 0 plus 0, your answer will be 0. And you repeat similar things. Okay, so this is the method for gray code to binary. So don't swap, don't swap, don't use this for binary to gray code. You're going to get different answer. So please make sure you remember where you're going to apply, whether from gray code to binary or binary to gray code. Because the method is very simple and very easy. Please play around also with the value, change with your friend as usual. Okay, is there any question for this part? There is exercise, you can try by yourself.
Doctor, what happens to the carry though? Like, why can't we just say 1 plus 1 equals 0 if, like, that's happening most of the time?
Because if you just want to apply, okay, 1 plus 1, you assume it's to be 0. Now, if I like make your mind to be this, later on when you want to apply like adding number, okay, let's say I have this number. Okay, I want to add. If you remember this kind, you will like doing 1 plus 1 will be 1. 1 plus 1, you will always tag as 0, and you don't have any carry, your answer will be wrong. You need to have carry.
Okay.
sum will be 0, and then your carry will be bring up here. Then later on you will meet 1 plus 1 plus 1. You will have also 1, 1. So there will be a sum of 1, there will be a carry. That's why I put now as a carry. So then later on you can apply in the real mathematical adding and subtracting. You need to have that carry. So if now you need to know, you need to discharge the carry. Okay. Is it okay?
Yeah, thank you, doctor.
Okay. So the explanation why I like mentions 1 plus 1 will be 1, 0, because yeah, later on you will use this thing. And if I just say 1 plus 1 is 0 for these things, gray code to binary, when you apply and go for next, which is adding, subtracting, you might confuse because you said, what I said last time, 1 plus 1 is 0, no carry at all, so it will confuse you. Okay. Any other question? So for next thing, we're going to have a parity code. I really don't like this parity code because sometimes it make me confused and I don't want to remember. I don't want to remember. That's why you can say that I always forgot things. Last time, I go to send my speaker to the shop because I still have warranty. My speaker cannot turning on, so I cannot turn on my speaker. What happened is that the shop called me and informed me that I can tag my speaker. I guess more than 2 or 3 weeks. I always forgot. So now I do what? I have a master student that she's quite close to me. She's my reminder. I cannot use my phone reminder now. I think I always also forgot if I put reminder to my calendar. So whatever things that important, I will ask and direct to inform my student. Please remind me, okay? I need to go to pick my speaker. Sometimes every day in the morning, she remind me and then suddenly I forgot. And then I said, hey, you need to remind me again. So that is funny things about me. I think not funny, but it's bad side. Next, in our parity code. Okay. As usual, also my bad thing is I don't like to read. You can read by yourself, but in terms of explaining, I will explain it in this part. Okay. You need to remember this table. Okay. You need to remember this table. How you going to apply? First thing, remember. Remember these basic rules. Remember this table, number, first, even, odd, even parity, odd parity. After you remember this table, then you can apply with your parity things, whether it is even parity or odd parity. Okay, when you have 1, 2, 3, 4, 5, 6, 7, 8, you have, let's say you were given with 8 bits of number. First, when you were given with number, you need to calculate first. Calculate the how many bits one that available. If you have even, what will happen? If you have odd, what is happen? Okay, now over here we have 1, 2, 3, 4, 5. 5 is our odd number, isn't it? So this is odd. Odd number, we're going to put, not put, we need to look into this. Because our number 1 is odd. 1, 2, 3, 4, 5. Odd ganjil. Odd ganjil, yes. Even, genap. So over here it is ganjil, so odd number. And your question will ask you to convert it to be as even parity. What you need to do? Odd, and you check even parity. Or if even, you need to apply 1 in front. Okay, next, I give you another example. If you have, okay, similar number, but the situation now is odd parity. The question asks you to convert it to become as odd parity. This is odd parity. You need to put 0 in front. So now this is your odd parity from 1 0 1 0 0 1 1 1. The question just now is this only, right? So you need to convert to even parity or odd parity. So you apply 0 as odd parity. I give you another example. Let's say you have 1 1 0 1 1. Okay. Now you have a even number. You have even. Why? Because you have 1 2 3 4. You have even number of bit 1. So this one, if let's say you were given this number, you need to please convert it to be even parity. Then your answer will be 0 1 1 0 1 1. Please convert it to be odd parity. 1 0 1 1 1 0 1 1. Because you look into this table. If you still not understand, let's take a look again. Another example. We have, let's say, 4 bit of data that we want to send to our computer. Instead, in our computer keyboard, we just press 0. We just press 3. We just press 4. We just press 7. But our machines, computer, laptop will notice it in terms of this 0101 value. Where is it? Okay, now you can see if let's say you were given this number, you can see there is no 1 at all. There is no value of 1 at all. So you will see it is 0 0 is even. So even number. So you need to remember the even, odd, even. Is it true? Table? When?
It's 12 hours.
Terbalik. Even, odd, even, odd. And the value will be like this. So now you have even value. Okay, you have even value. If you want to convert to be parity, even parity, you need to add you need to add 0 in front because you need to even parity. If you want to have odd parity for your even number here, not even number, even numbers of 1, you will add 1. Over here, next example, you have 3 bits for 1, digit 1. Then what you need to do is you have odd number, and when you want to change to even, you need to add 1. If you want to have odd parity, you have 0. See, this is all the parity bit. So you can try this and this. Is it okay or not?
Doctor, can you go one slide to the back
Okay.
for the table just now? The small table. Okay. For one of them. Okay.
Doctor, so the question will be convert to even parity or convert to odd parity, right?
Yes.
It's not only convert to parity.
Sometimes maybe you were given the tricky part, which is vice versa, which is you were given with this even parity, and then maybe you need to find the value of the bit number. You know that all in front is parity bits. If let's say it is even parity, you can just calculate how many bits and you apply vice versa things.
Okay, got it. Thank you.
Okay. But normally this is all the basic thing, and in the question we will like go for advanced. That's why it's not like too direct. Okay. There is also another example here. You can try also. This is the answer. You can just screenshot and try in your notes and slide. Okay, what is the purpose for your parity? This is happen when we want to send like any message to any two devices. What time 12? When we like sending, sometimes there is data that lost, especially when we can see like very clear explanation. When you go to camping or what camping bina semangat, something like that, when there is instruction, maybe it give you instruction copy and you send to next person until the last person. It's not going to be copy, maybe it's going to be copy. So means that while you send any data or any information, sometime in the middle there will be an error, there is a data loss and etc. So that's why you're going to check an error detection by using parity checking. So you can like try to read more in your module. But this is example for you. If let's say you have this number for even parity, you will get this value, and this is your parity value. When you want to like send to another value, you can see there is a possibility for you to have an error. So this is basically an error you can get. But if let's say at the point B, you have the even parity of 00001, does not confirm to have the even parity. It is not similar to the data that you transmit. So odd number of 1 not even, you can see. So over here also you will notice that there is an error, because you're going to see this is even parity and your value over here is also even. So you make sure you're going to have 0. But later on when you send, you see that the value 1 over here is wrong. So you're going to see, oh, there is an error when you transmit. So this is just for you to apply, where you're going to apply parity checking, especially when you are sending the data. So that is on our first BCD, and then our gray code and parity. And now we go to ASCII. ASCII, I quite light because the table will be given directly in the task. So we just need to know how to use the table. There is several table that you need to apply. So here we're going to look into. In our daily life, we know this is A. This is also A. Basically, it's similar, only the difference with the capital and small letter. And in our machines, to differentiate it, they will not knowing that this is A, which is similar. But instead, they need to know, okay, this is capital letter and this is the one that machine learning understand. This is A for a small letter. So this is just example of value. I don't know whether it's correct or not. Later on, you will check in the table of ASCII. And a parity bit is added so that total number is 8 for 8 bits, which is a byte. So this is for ASCII. So please make sure you remember just now, if you still remember for BCD, we use 4 bits, right? For ASCII, it is 8 bits. And you're going to have 1 to 8, or including the parity bit is going to be 8 bits. And the total is 4 bits altogether for the codes. Let's take a look into the table. This table, if you are card as well, I don't know, KYLE, card as well. Did you heard about this drama series last time? Or maybe you are first gen, you don't know about Z gens. You don't know, this is quite old, but this is very good drama series, which is I love the hero and heroine. The heroine is very beautiful and the hero is very very good person, which is very lurus. Lurus, very honest, and the car as well can, if you just give this picture, he can memorize every single things. So maybe you can try to find Carl as well, and it's very interesting story. And over here you can see you were given the decimal number, hexadecimal number, and ASCII number. So you have the possibility to be given with the binary number also, but how you going to convert to get the ASCII code? Or sometimes vice versa, you were given the ASCII code over here, you need to find the hexadecimal value or also decimal value, or maybe binary value. It depends because you were given the tables already. There is another table like this. You need to know how to apply it. Let's we see the example. I give you example first, then we look into the slide example. So I just pick any number I want as long as it is 7 bits. 1010, the easiest one, I think. Okay. If I have this kind of number, binary number, I want to convert to ASCII code. What will happen? We need to apply this table for these 4 bits over here. I will take a look 0101. 01. Okay, this part. And another one is 101. 101, this one. So let's me take a look into the things. Okay, when I press 2 at my keyboard, basically my computer will get these informations. So this is the way for you to get and use this table. Okay, let's say we have the example of, yes?
We group the ASCII code from LSB, right?
Yes.
Okay.
Normally we will start with LSB, because our numbering system also we will like doing like this, right?
Understood. Thank you.
So over here, there is another example. You can see we will take this 1101, 1101, and another one is 110. So my answer will be M. Vice versa, let's say you were given M value. Let's say you were given M. So M, you need to, let's say, find out the value of this one and this one. And you need to combine it together as long as you know where is the dia punya kedudukan. But wait, you can see also sometimes you were given this table. If you were given this table, let me see the example of M just now. One zero nine 65. 60 109 106 109. Can you try to convert this one? Can you get the similar answer for the binary? Is it similar? This one is decimal. This one is hexadecimal. And this is binary. M for ASCII. Did you convert or not?
Yes.
The answer similar, right?
Yeah.
So you can apply in terms of this way of table, and you can also be given with this table. So you just, as I mentioned, you can also have the binary convert later on, and the hexa. If you have the ASCII, you need to find like hexadecimal. If you were given with hexadecimal, you need to find the ASCII, as long as you know how to look into the table. So over here also there is another example. Example over here, you can see this is the table and you were given the ASCII. Now you need to find the hexadecimal value. So the ASCII is S, capital letter S. I will get 53. And C, I will get 43. R, I will get 52. 1. Where is my 1? 31. 0, 30. 1 again, 31. And 3 will be 33. So this is the hexadecimal value from converting from my ASCII. And you can also change later on to be in binary. It's quite long, of course. So you can change later on to binary 101010. Either one. In this question, you just been asked to convert to hexadecimal. So you can also take a look into the several questions I provided here. Let me charge my laptop. Wait, Okay, so you can try to play around with the table if you are a kind of KELUARGA. Maybe after you watch KELUARGA, you want to try to see whether your mind and your brain can remember this table. You might try and try to convert the hexadecimal value, and then try to play with odd parity. You put at MSB and recalculate it back after you apply the odd parity inside. So maybe you can like draw this table and find the new ASCII code. So only that for our 2B. We will continue with our 2C, but we're going to take a break. So is there any question for our ASCII code? Before we take a break, after this we will continue with our module 2C. Let me ask someone here. In terms of your own understanding, siapa ni? Muhammad Socks. Is it Sock? Muhammad Marzo Sock. How to pronounce your name? Muhammad Marzo. Marzo. Okay, Muhammad Marzo. Let's say I share you my screen, okay? Let's say I have this kind of number. How I'm going to differentiate whether this number is positive or negative? How I'm going to figure out whether this is my positive number or negative number in your your own knowledge? How you going to differentiate?
There are like two ways I know. One is to use one bit as like identifier for the negative sign, and there is another way we use. I think I don't remember this. Like we convert the zeros to one, and the last bit we add one.
Okay.
I think so. That's it.
Okay, thank you. I think you when you said about adding at the last bit, I think it is second complements, but
I
yeah,
think it's
it's
something magnitude.
for the
Two
magnitude.
complements, I think.
Yeah, this second complement, first complement things, but you can also have the 0 and 1 in front of your MSP side to figure out whether it is positive or negative. But thank you for your answer, because you like already advanced to know the second complement, first complement, because for second complement you're going to add the value at the back, which is you will add 1 from your numbers to be a second complement. But this one we're going to continue after this. We take a break first, go and get a drink, and we will continue at 12:25. Okay. Firdaus internship SV apa benda? Hello, we be back. Sorry, I go to ladies for a while. Tired. Okay. Now we will continue. Are you all here? We will continue
Yes, doctor.
with our module 2C. Here we will look into our signs number, unsigned number, and then there is also additional. Okay. Okay, so from here for our next, which is before we end our module 2, we will look into the arithmetic operation. For the arithmetic operation, of course, if it is look for our mathematics, we will have like additional, subtraction, multiplication, division, and etc. But we just look into additional and subtraction only. And in our arithmetic number, normally we have unsigned and signed number. But it's easy for us because we already like familiar with all our integer number. So we can just always like put positive 7 or negative 7 to represent our number, whether it is positive or negative. But when we play around with 1010 binary number, it is hard for us, and because we cannot put like positive 1010, there is no casting like this, negative 1010. So instead of this positive negative, we need to change this representation. We need to change to be as numbers also. So you can see later on, after you already learn on unsigned and signed number, you're going to look into range, lower and high. Okay, later on you will see. Let me proceed first. Okay, for unsigned number, we are under unsigned number. We are under unsigned. You can see that for unsigned, we have no negative value. Of course, because the unsigned will be, we assume, as always positive. There is no negative value. And the positive value is starting from 0 until, infinity. But when we have like a limitation, let's say we have putting, apa ni?
Servis tu 2 kali hantar tapi tak dapat dia sebab handset kita call dia tak boleh masuk lah. Doktor boleh beritahu student ini nak sebab 2 kali kalau dia masih tak dapat itu buku nanti dia return.
Let me check whether it is from your section or not. Muhammad Kamil Izzat.
Yes, doctor.
Hey, what happened? Your phone number is wrong, so your books cannot be delivered.
Doktor, student ni itu servis hantar.
Your courier server is already 2 times try to send to your house. Is it your number is correct or not? Wait, there is quite loading. Is it correct?
Try give it my second number.
Okay.
017
Yeah. 017
99
99
22 036.
Why you don't put, and what happened to your this number?
I don't know.
Right. Correct or not? This number.
I use the number, but I think I put it in iPad and the iPad is in the car.
But the courier is already 2 times sent. So supposedly yesterday they tried to send. If you look, 27, 28 delivery. Already. Since last week, I guess. But it's okay. Already update. Ayo. Next time, just put your mobile phone that existing you are using.
Okay, Doctor.
Sorry, go back to our class. Sorry, there is a advertisement. But this is important because the courier want to send again today. That's why they asked to update the phone number. Okay, for our unsigned, as I mentioned, you will have 0 until whatever infinity. But if you were given the question and it's give you limitation with the number of bit, so you need to know this is you need to apply. Similar also to your number, the small, okay, the small one, which is if let's say you were given only 3 bit. 3-bit number, you're going to apply to the power of 3 will be 8. So you have 8 possibilities of numbers starting from 0, 1, 2, 3, 4, 5, 6, and lastly is 7. That's why this you apply like to the power of n will be 3 minus 1, then you get 7. This is the equations of to go for you to get the range for unsigned number. In this part, if let's say you have 3 bits, because I'm too lazy to have long versions. If you have 3 bits, your range will be from 0, 0, 0 until 1, 1, 1. And if you convert this 1, 1, 1, you will get 7 in decimal. That's why your range will be 0 from 0 to 7, and total will be 8 because to the power of 3. Similar to if you have 8 bits, you're going to have similar things. Next is still under your unsigned number, is basically similar for you to get the range. Range of value, the largest value of the range. And when you have a word is 16 bits. You can also find the range to apply to the power of 16 minus 1 for the highest or largest value. And all total you get to the power of 16. The total including the 0, 1. So this thing you can read and it is easy for you to understand. For unsigned, that's why I mentioned range of number. You might also be asked, what is the range of number for, let's say, 17 bits? So you need to apply this equation. Example here, find the range of binary number that can be represented by 10 bits. See over here, it is 10-bit now. But as similar, you're going to apply 0, 2. For unsigned number, it's easy because you just started from 0. You will always have 0 as the started point, and the maximum or the highest value or range you're going to apply to the power of n, and will be 10 now minus 1. So what are you going to get? 0, 2, 1, 0, 2, 3. I don't want to calculate. You can try to calculate it using your calculator. And because if you have the range, you're going to have the upper bound and lower bound, and your lower bound will always 0 for unsigned number. Later on, for signed number, this lower bound value will be vary and will be different. So it's apply an equation. Later we will look into the equation. But for now, please make sure you know for unsigned, it will always 0. So you are given the bits, and then you need to find what is the lower bound, what is the upper bound. So the range will be 0 until 4095. Altogether you have 4096, including the 0. Okay, after we know our unsigned number, because it's very easy, too easy, now we will like very confused when we apply our signed number. We will look into how we're going to represent our sign, and we will also look into the equation for the range, lower bound and upper bound. First of all, if you still remember in our gates, I always say to you, if you have 0, it always low, off, false, and I did mention anything that negative, isn't it? Anything that negative, it is a 0. And 1, when you have 1 over here, you will have like on, true, high, which is positive. But for sign number, you're not going to apply that. But it's vice versa. For you to represent the sign number, if you have positive, you're going to place 0. And when you have negative number, you will have 1 as a representations at the MSB side. So you can read by yourself, but I can explain in terms of my way. Instead, I read. So over here, you can see 0 for plus, positive number, 1 for negative number, and you're going to put it into your MSB. Example, you have this number only, and when you want to represent it as positive, you're going to put 0 in front. If you have this number, you want to represent it as positive, you put 0 in front. Negative, you put 1. Negative, you put 1. Later on, we will see on the bit and etc. Okay, but just to show you first, 0 for positive, 1 for negative for sign number. It is refer your positive and negative symbols. Instead putting this symbol, we will put the value of 0101. As again mentioned, our computer won't understand our positive or whatever versions other than 0101. Okay. Boring lah warna merah. Kita try tukar warna biru pula. Okay. Over here, you have a simple versions of 4. We change the magnitude first. We will apply 1, 0, 0. This is on the magnitude or also the value, right? Then you have positive. Positive, you will put 0. This is the simple just that. And path 8, 4, 0, 0. And you have negative. This one is the magnitude. Negative, you will put 1. So let's take a look the answer. Very simple. You can try to find the try to do this example also. This is the value on decimal. This is the value on decimal also. You can see this is your value of your magnitudes, but in front of it there is a 0 or 1 to refer to the positive and negative. Easy, right? And after you notice and you remember the positive and negative 0 and 1, later on you're going to see that there is an equation for lower bound and upper bound, and you get the range. Where n the total bit, n is your total bit. Let's say you have example. I give you of course the simplest one. I don't want to make hard. For my lower bound, let's say I have bit 3. 3 bits of number. Then my range will be negative to the power of 3 minus 1 minus 1. And this is my lower bound. I will get 2 minus 1. Negative 4 minus 1, I will get 3. So equal to, is it correct? 2, 3 minus 1. 2, 4. Okay. Then I will get minus 3. And then this is for my lower bound. This is my answer. After that, for my upper bound, I'm going to apply 2n minus 1 minus 1 for positive. But this is basically similar things, only that is positive, so I get positive 3. So my range of number for 3 bits, the range will be range. And all together, I will have to the power of 3, 8. Isn't it? So please try to check it. Isn't it? No. You can see there is a negative 3 until positive 3. So let's take a look the value negative 3, negative 2, negative 1, 0, 1, 2, 3. 7 value only to the power of n supposed to 8. How come? Oh, because this is unsigned number, this one will be there is 2. There is an exception, it's not going to be to the power of n because this is signed. And you're going to see you have this method. You're going to see, okay, 0, 0, 0. Let's say for my 3 bits, right? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. So I have this kind of number first. And then this is my 3 bits. This one will be my my sign. This is my magnitude. And you can see over here, this is 0, this is 1, this is 2, and this is 3. When we continue to be 4, 5, 7, you can see it will be 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 4, 5, 6, 7. So this is a positive number. If we convert this one, this is in terms of how we represent the value, but the magnitude is inside. 0, 0 will be 0, 0, 1 will be 1, and 1, 0 will be 2, 1, 1 will be 3, 0, 0 will be 0, 0, 1 will be 1, 2, 3. And sign, positive, 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 positive. This one, of course, plus, minus, negative, but this is no representation. Basically, 0 we will assume as to be positive always. Negative, negative, negative. That's why this one we will just ignore it. We have the range of 0 to -3 until +3. This is the range. Lower bound, upper bound. This is basically similar. Only in terms of, because magnitude is same, only in terms of the signal, our sign. Our sign, whether it is positive or negative. This is a section for your sign number. Beside this, you're going to see in terms of table, so it's likely okay for you to understand. You can see when you have, I prefer it to be upward like this, 0, 0, 0. When you have 4 bits, the first bit which is your MSB will be a sign. Magnitude will be another reminder of the bits. So this is your magnitude, and this is your magnitude, and this is your sign. You can see you have 0, 1, 2, 3, 4, 5, 6, 7, and your sign will be positive, 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 positive. And if you continue, you're going to continue with, there is no 0, 0 at all yet. You're going to continue with 0, 0, 1 directly. 0, 0, 1, 0, 0, 1, which is you will continue. Supposedly you have 1, 0, 0, but this is basically similar to the one here. So you will continue with 0, 1, 0, 0, 1. This is the magnitude of 1, and the sign will negative, and until -7 for 4 bits. Is it okay? So about the range, this is the equation for you to apply, depending on how many bits that available. So inside is your sign, and magnitude will be at your left side. Over here, you can see there is also example. So this part, you're going to have positive, and this is negative, and you have 1 in front, and this is in front for the positive. This is basically the value for 25. If you direct convert, you will get 11001. This is the value of 25. And you were given with 8 bits. 1, 2, 3, 4, 5. You only have 5. That's why you need to have another 3. And the first MSB will be your sign. So because it is positive, you put directly 0. And the rest will be 0, 0. Similar to if you are having the negative number, you have another 3, right? So first of all, you put the MSB part. If let's say negative, you will put 1 and the rest will be 0, 0. That is on your sign and also your unsigned number. This is for you to like apply 0 and 1 only. And please make sure you remember the equation. Is it okay or not?
So the last part, the question asks for 8 bits, so we just add zeros until it's 8 bits or?
Yes, because 0 will not affect your value. Because as I mentioned, this will be your magnitude and this will be only your sign. Sign is only at the MSB. So the rest will be magnitude. If you put like 1, 1, so your value and your magnitude value will be vary or different, right? So that's why you need to just put
Okay, got it. Thank you, Doctor.
Okay, let's move to another. We're going to look into first complement, second complement. I think we cannot finish the slide today, but let me finish the first complement. Okay, when you have the value, just now we learned the sign number. If let's say I have easy part which is positive 3, let's say I have positive 3 and I have negative 5. I want to add this kind of two number, and I know for my positive, let's say for 4-bit number, okay, I have 0, 1, 1, 1, 1, 0, 2, 1. Correct, right? And I have 1, 1, 0, and this is my value of magnitude at 5, and I put 1 in front. This is 3, this is 5, and we put 0 as a positive, 1 as the negative. Okay, if let's say we direct it, okay, if I just add these two number, I will get 1. I will get this kind of number which is totally, it is supposedly negative. But if I add this number, I give you wrong that you cannot see. Okay, let me try to give you another question. Okay, maybe here I put 7, so it will be 1, 1, 1, 1. Okay, 0, 1, 1, 1 plus 1, 1, 1, 0. Just want to show you that you will get a possibility of an error. 1, 1, 1. Supposedly, when you add 7 positive with negative 5, you will get positive 2, isn't it? But when you just direct apply using the sign numbers, you will get negative, and your value of your magnitude also wrong. That's why it's come out for you to use adding for binary sign number using complements. First complement, second complement. Okay. So first of all, we're going to learn on first complement. After that, we're going to learn on second complement. There is a step for you to do. For first complement, if the number is positive, you just ignore, which is, of course, you just apply a similar things, which is you put 0 in front. No need for you to apply the first complement if the number is positive. It's only apply for the negative value number. Okay, this is the first thing that you need to know. If you have positive number, no need for you to do anything. You just use a similar sign, magnitude, things that you already learned, which is you add 0 in front. But when you have negative, you need to apply the first complement.
It's 13 hours.
How you going to apply? You just change the value of 0 to 1, 1 to 0. Let we see this example. If we have this kind, we just change it to be 1, 0, 1, 1, 0. And before that, we need to 1, 2, 3, 4, 5, 6. If let's say it's 7 bits, we're going to add, assume that it is 7 bit. So we put 0 first in front. It will be 1, 1, 0, 1, 1, 0, 1. Because we already assume. It depends on the question. If it's directly give you without mentions any numbers bit, then wait, I have a WhatsApp. Let's open it. Okay. It's depend on your question. As I mentioned, it's depend on question. Over here, it's already mentions that assume it is 2-bit binary system. That's why, first of all, if you were given this question, you read, okay, this is only 6. Then you need to apply 0 in front. Okay, this is the 7-bit. And when you want to apply the first complement, you just change 0 to be 1, 0 to be 1, 1 to be 0, 0 to be 1, 0 to be 1, 1 to be 0, and 0 to be 1. So you will get like negative value also just using the first complement. This is just a simple one when you want to have the first complement. Let's say you have integer 4 bits. Your value of magnitude is 7. You will have 1, 1, 1. For positive, as usual, no need for you to apply the first complement. What you need to do, you just add 0, 0, 0 in front. This is the first complement, which is similar to the sign value, which is we just add 0. But if you have negative, what you need to do is, of course, first when you have 0, negative 1, you will have the value of like this 0, 0, 0, 1, isn't it? Because it is 4 bits. 4 bits, and then when you change it, you will get 1, 1, 1, 0. Like this also, you have 1, 1, 0, 1. You just change the value 0 to 1, 1 to 0, 0 to 1. And of course, you're going to have another 0 because it is 4 bits. Okay. And over here, it's also similar. This is an example for -7. You have the value of 7, 0, 1, 1, 1. And then you convert it to be first complement. It will be 1, 0, 0, 0. That is the only for first complement. After this, next class, we will have second complement. But later on, maybe I will also share the video so that in class we just do a recap. Because there is only a few things left for this slide. before we finish our module 2. Any question for first complement, ASCII, and etc.?
Doctor,
Yeah.
all these is ways of representing like negative numbers, like sign numbers, first complement, second complement.
Yeah, it's going to for negative number because the problem that we will face is on the negative number, not positive, especially for the adding and subtracting later on. That is the only purpose, which is if you adding the negative number and if you subtract negative number using the sign number, right? You're going to get error. So you need to apply second complement, first complement for addition and subtracting using binary.
Okay. So second complement is like an improvement over the first complement.
Yes, you need to
Oh,
have the
okay.
flow. So after
Okay.
you convert for first complement, then you just add 1. You
Okay.
add 1 value, it's called as the method for second complement. So you add 1, then you will get second complement. So it's not too hard as long as you know, okay, first complement, you just convert 0 to 1, 0 to 1. And then for second complement, you just add 1. This one will be adding. Where is my pen? This one is just add. 1 plus 1, you will get 0, 1 with the carry of 1. 1 plus 0, you will get 1. And then you just remain the same as over here. This is your second complement. And this is the one that you will use for adding. This part, right? So you will bring this part and you will add with any number, whether it is negative or positive, and your answer will be correct. Not the error one that I mentioned when you want to add 7 plus with negative plus, right? So you get an error, right? But after you already convert into using a second complement, your answer will be correct.
Okay. Thank you.
Okay, but later on we will look into about this, which is carry bit is ignore, whatever things. There is a several things that you need to know also in the second complement. Okay, so if there is no more question, we will end our class today. If you have any problem, you can just WhatsApp me. Tomorrow there is no class. I have only session 09. We meet again on Monday, next Monday. We don't have class on Sunday, so that's why I hope that I can just provide you with video. And next Monday we will proceed with our lab 1. Please make sure you try your DIT simulator. There is no stress or pressure using DIT simulator because it's very easy. Just play around with that, okay?
Doctor,
Yeah.
may I know which simulator that we use?
DIT simulator.
Can you type it?
Okay, wait. And direct give you the link, okay?
All right.
Here, and I will give you in the WhatsApp group. Because I have the old version, I think whether it is similar or not. And just directly, it is free and I think it's quite small, not too big in space and RAM. So you can just go directly, go to the download and you download. Wait lah. Abang, semayang. Kat sana ada kain. Oh. Okay, I have the older version. So it's good for you, just for you to download. Maybe I can share this tab. Okay, you can see over here. This link I provide you already. Click download and then you download the latest one because I have the oldest one. You can run this also in other Mac. Hey, this year already got Mac. But using a crossover, I don't want. So that is the only things about this that you can see, and you will play around with the this with the gets and etc. Play around with the input output value, a clock. For our lab 1, maybe after this I'm going to upload the lab module so that you can play around with that. Is it okay?
Okay, doctor.
Okay. Any other? If no, we're going to end our class. Meet you again on next Monday, okay? Bye-bye.
Thanks, doctor.
Thank you, doctor.
Thank you,
you,
doctor.
Thank you, doctor.
Thank you.
Thank you, doctor.
Bye-bye. Yes? Jun?
Thank you, doctor. Bye bye.
Okay, bye.